Well, actually, we don't. We don't have a washing machine here, and also it would use up a lot of water, and water is very scarce in space.
Astronauts traveling to the ISS do not wash their clothes. Clothing supplies is given to them through deliveries of food and other needs. But once back on Earth, their 3 months of outfits are washed the same way we do, with washing machines, consuming energy and water. So if we are limited by this situation near Earth, can you imagine what it will be for Martian settlers when they leave Earth for a 6 months travel?
So our solution basically is a belt which expands as a full suit. So the design is clear to be ergonomics, easy to use, and easy to personalize for any kind of fashion.
We've decided to follow a very specific life cycle that would enable the cloth to be sustainable in Martian colonies. In the first place, the polymer, shape membrane polymer, would be made out of starch, so basic potatoes, that would be harvested within the colony, then the cloth created, and as this material is recyclable and really sustainable, after a couple of time when the cloth is used and dirty, we can just recycle it and create a new one really easily.
New Eden will serve as a beating heart for the first human settlement. It is an ever-replenishing well that provides colonists with the fundamental necessities of life: food and water. Every great journey grows from a small first step. That step is New Eden. This innovative system combines the current pinnacles in agricultural and water processing technologies, then pushes further. Harnessing mist-based aeroponics farming, New Eden is a network of modular aeroponics pods capable of growing a targeted selection of crops at a faster rate while consuming a fraction of the water when compared with traditional soil-based agriculture. These crops are specifically tailored to provide all nutrients that colonists need to prosper, maintaining body fat, muscle mass, bone density, high energy levels and a healthy immune system with an entirely plant-based diet. Through seed vaulting, cross-pollination and staggered growth across separate pods, the biomass will be protected against disease and provide a consistent year-round food source. Each pod is sealed to contain a nutrient-infused mist for reuse. Combined with the reclamation and treatment of human waste, New Eden is a near-perfect closed loop of water and nutrients, yielding high volumes of food with minimal water loss and waste. Our forebears made landfall on plentiful lands, where natural resources were abundant, but Mars offers no such sanctuary. It is a brutal environment with scarce resources where a long-duration settlement is impossible without precision engineering that pushes the limits of agricultural and water processing efficiency. The initial New Eden system can be transported via SpaceX BFR to a site in the Malus Chasma, where water ice is abundant within the ground. By harvesting a baseload of water ice and a first generation of seeds from Earth, New Eden will provide a sustainable garden of food and water in the harshest climate ever faced by human settlers. This landfall payload, the initial stage of New Eden, will allow the first generation of bold explorers to establish a beachhead for colonization. Beyond its core function of food and water production, New Eden offers its true innovation: self-sustained growth. The primary architecture of the aeroponics pods and the supplementary water treatment infrastructure are constructed via 3D printing from an organic polymer, polylactic acid. PLA is sourced from a primary New Eden crop, soybeans. A portion of these legumes not consigned for nutrition is stored in surplus for processing into building materials. As the colony expands over time and more astronauts arrive from Earth, the food demand will inevitably increase. Additional pods, water tanks, pipes, valves, nozzles, filters, and other New Eden hardware will be printed and installed to increase agricultural output. Only a limited number of small, highly specialized machine parts must be transported from Earth, easily carried by newly arriving colonists, requiring no additional dedicated supply missions. Eventually, these complex components will also be produced on Mars, as the expansion of base facilities and skills allow more sophisticated manufacturing. The development of New Eden also has profound implications for the agriculture on Earth. As human populations rise over the next century, there is a critical demand for high-performance agriculture to feed more human beings whilst tackling climate change due to the habitual abuse of Earth's resources. By conserving water, increasing yield, and bringing a healthy food source closer to urban consumers, New Eden can be applied to solve mankind's greatest challenge: protecting the planet we call home. Once established, New Eden offers a sustainable flow of locally sourced food and water. With a carefully tailored plant-based diet, colonists will live with unparalleled efficiency and nutrition. This ever-growing system will support the expansion of a sophisticated Martian settlement, unlocking boundless possibilities and a new era of discovery.
In our team, we didn't know each other before. We gathered only because we share the same passion for space exploration and Mars colonization.
We wanted to tackle the issue from the very beginning. That is why we decided to design a food production system. We made research to know the needs of a 100-people colony, and we crossed the data with the plants that would grow on Mars. It was clear that plants were not enough. However, it was too expensive to produce meat. That is why we added insects to the diet.
We wanted to do more than just some kind of farm. The idea was to think of a whole system of self-sufficient supply chain. In this sense, we designed a waste management system using bioreactors.
The culture of insects has many advantages. Insects can easily convert waste into edible biomass or fertilizers, which is a huge asset on a planet where the soil is not tailored to agriculture and where resources are scarce.
My name is Camille and I study industrial design in Paris. When Luca told me about this competition, I was really excited, and so I started looking at what kind of design is usually used for projects on Mars. I realized that every time the architecture was kind of futuristic, and so I wanted to design something different that would integrate more in the landscape. I really wanted to reduce the visual impact of the architecture, and that's why, for example, the roof looks like kind of a big rock that reminds those you can see on Mars.
This food production system was designed for a 100-people colony. It is built partly underground to limit cosmic ray and take advantage of Mars geology.
To find the best tailored diet, we used optimization algorithm, which found a compromise between matching the nutritional needs, keeping a food diversity, and what could be produced.
Then we could calculate the surface of the farm and quantify our design with numbers, which was very important for creating a full supply chain. Because of Mars conditions, fertilizers had to be added to produce the food humans are eating. And that is the greatest part. Fertilizers and nutrients are provided by human waste and insects, thanks to bioreactors.
Bioreactors are a piece of technology converting biomass into fertilizers. We found the parameters knowing the waste produced by the colony and what nutrients our agriculture needed.